Hello, viewers. Good morning. Good morning, viewers. Hello. Gonna wait for, I don't know, 25 or 30 of you to join in. So I was reading a crazy article this morning talking about how the chemical phosphine was discovered in Venus's atmosphere. And so the amount of phosphine that was discovered was much greater than the amount that could be produced by known sort of geological processes. And furthermore, this chemical is broken apart by the sun. So basically, there's an unknown process producing phosphine, and it's actively happening because otherwise the level of phosphine would be going down due to the sun's rays breaking apart the molecules. So, it seems to signal that there could be life in Venus's atmosphere, which would be kind of cool. Because that's one of the last places that astrobiologists would think to look, because so that could be really big news. Gonna wait for a couple more viewers. Hello, everyone. Dum-de-dum. I'm gonna wait until we get to 25 viewers. All right, we're at 25. Okay, hello class. It is Monday. You had your first programming assignment was due on Friday to code board. I think if you didn't complete it yet, you can still submit it. I don't have like a hard deadline where it cuts you out once the deadline passes. So if you haven't done that, make sure to turn that in today because I'll probably be looking at it in the next few days. I also want to remind you to submit your daily attendance. Okay. So what are we going to be doing today? Well, I'm going to be talking to the IB Physics SL students about classes. Okay. So I'm going to teach you how to write a class. And this might have been covered a little bit in the regular computer science class. I'm not sure. I found some assignments pertaining to classes, but we need to know a lot more about classes this year. That's going to take about 20 or 25 minutes, and then I'll be talking briefly about two recursive algorithms that I will be sharing with the IB Physics HL students. So the HL students stay on this live stream. You can watch if you need a review on how to write a class. But stay on the live stream, and then in about 20 minutes or so, I will call for you guys to come back and pay attention to me. Okay? So let's go ahead and get started. I'm going to switch over to code board. And so I'm going to start writing a class. So let's see, I have some questions about how my weekend was. My weekend was okay. I kind of stayed inside because of the air quality. And I still feel congested. All right, so I have code board here. Let me make it bigger. And so first things first, if I define a class, the file name has to have the same name as the class, okay? .java. So I'm going to create, as most of you probably know, I'm also the physics teacher, and so I think about vectors a lot, and so I'm going to write a class called myVector. So I have a file called myvector.java. And so you'll get a compile error if you define a class that is not the same as the file name, okay? So I'm going to say public class myVector, okay? And this block of code is going to have the definition of my class. So first of all, what is a class? A class is a template for an object. So an object, Java is an object-oriented programming language. And so a class is a template for an object. So what does an object have? An object has data, which I will call fields, okay? And then an object has methods, or things that it does, okay? Hang on a second, I gotta let Hazel out. So a class has fields and methods. So the fields are basically data that the class contains. And then the methods are actions, things that the class can do. All right, so a vector, as you recall from your math class, has an x component and a y component, and a z component, but I'm just going to make a two-dimensional vector class. So I have 2 bits, 2 fields, the x component of the vector and the y component of the vector. So my fields are going to be they're going to be doubles. So that means that they're basically decimal numbers, x and y. Okay. If you're not familiar with what's going on in line 3, you can define multiple variables of the same type on the same line if you separate them by commas. Okay. So we have an x component and a y component, and those are the fields. Okay. Now, one of the things I want to do is I want to add an access modifier. So I could say, for example, public double. But that's not what you want to do for classes. You want your fields to be private. So what does that mean? It means that the only thing that can access the fields is the class itself. Okay, only the class can access those fields. All right. And so this philosophy is called data encapsulation. So we want to control access to the data. Okay. So by making that private, I'm controlling who can access, what other objects can access the x and y component. Okay. And then you have, for classes, you have to have constructors. you could have one or more constructors. So I'll put parentheses S. And so basically what the constructors do is they set the value of the field. Okay, so the constructor has the same name as the class. So I say my vector, and what if I made a constructor that takes in no arguments? So it has no arguments. So this kind of a constructor, maybe I will set x equal to 0, and I will set y equal to 0. So basically, when I define my vector object, then I'm setting the x component and the y component equal to 0. So back over here in the main file, I could say, for example, if I wanted to create a myVector object, I would say myVector v equals new myVector, and this is the constructor call. So see how I have myVector with no arguments in that constructor. So this is going to create a vector, a myVector called v, that has an x component equal to 0 and a y component equal to 0. Okay. But you can have more than one constructor. Okay. So for example, let's say I wanted to make a constructor that takes in a double x and a double y. So this is a 2-argument constructor. This is a 2-argument constructor. So I could say so one of the things we got to be careful about is the arguments of the constructor are called x and y, and then the fields are also called x and y. So this can be a bit confusing, so we have to differentiate between the two. So you're going to use the this operator. So anytime there's any confusion between which variable you're talking about, you say this dot x. Okay. So that means when I say this dot x, I mean for this class. This class's variable, this class's field x. I'm going to set it equal to x, so this dot x refers to that x right there, and this x refers to the argument of the constructor, and then this dot y is equal to y. Okay, so that's a second constructor where you're not setting the components of the vector to 0, you're setting it to whatever the user chooses. So back in my main function, if I had my vector w equals new my vector, and let's say 3.0 comma 4.0, then this one, the my vector w is going to have an x component of 3 and a y component of 4. So what the compiler is able to do is it's able to look at the arguments that you put in to the constructor, and it's going to choose the right constructor. Okay. If I tried to say my vector z equals new my vector 3.0, that's going to give me an error because this constructor has one argument, and I don't have a constructor in my list of constructors that only has one argument. It either has no arguments or 0 arguments. So that would give me an error. So that's no, don't do that. remove that. I think I also need to. Okay, so that's constructors. The purpose of constructors is to set the value of the various fields. So now let's talk about methods, which are actions. Okay. One type of method is called a so-called mutator method. Okay, so a mutator method changes the fields of the class. Okay, so they change the value. So for example, and methods are functions. So we have public, we have an access modifier. You want your methods to be public most of the time. Then you have a return type. So this is not going to return anything. So public void set x. So that mutator method is going to change the x field for this class. So I have double x, and then the body of code for this is going to be this dot x is set to x. Okay. So this is going to be after we create the object. If we then decide we want to change the x component, we can do that by using the set x mutator method. Okay. Mutator method, again, is a term for a method that changes the fields. Okay. Analogously, we could have a set y method. So double y. And that's going to set the y component. So we can change the y component of the vector. All right? So those are mutator methods. If a particular class does not have mutator methods, then once an object is created, its fields cannot change. Okay? So it's stuck. Once you create that object, it's stuck like it, it's the way it was when it was created. So if a class has no mutator methods, it is called immutable. Okay? Immutable means no mutator methods. So an example of an immutable class is a string. You cannot change a string. Once you make a new string object, you can't change it. If you set a string equal to something else, really you're leaving that string the way it was and you're creating a new string. Okay? Another kind of method that you have is accessor methods. An accessor method is going to return the values stored in the field variables. Okay, so for example, I could have a public, and it's going to return the x component. Okay, so I'm going to call that the x component is a double, so the return type of this method is double, and it's going to be get x. Okay, this doesn't have any arguments because it's just going to return the x component. So the code is very simple. It's just going to be return this dot x. Okay. Another accessor method would be to get the y component. return this dot y. Okay? So those are accessor methods. We can also have other methods that do other useful things. So one example is that I thought of was a public double. So it's a method that returns a double, get magnitude. So the magnitude of a vector is the length of that vector with the Pythagorean theorem. So I'm going to return, so I'm basically going to do the Pythagorean theorem, return math dot square root of x times x plus y times y. So that is the Pythagorean theorem. Okay. Another method, so another common method is toString. So public string toString, which is going to figure out, so the toString method is basically saying what happens if we want to turn this object into a string. Now you might know that with vectors, vectors are often, like if I have a vector with components 3 and 4, you just put them as an ordered pair. So my toString method is going to do that, okay? So I'm going to return, and I'm going to make a string, okay? So I have the opening parentheses, and then I'm going to concatenate on the x component, and then I'm going to concatenate on a comma, and then I'm going to concatenate on the y component, and then I'm going to concatenate on the closing parentheses. So that's going to basically give y component. All right. So, and then there's one last method that I want to define, which is an equals method. So equals is going to return true if the two vectors are equal to each other, and false if they're not equal to each other. So this is going to return a Boolean variable, public Boolean equals, and I have to see what is it equal to. So I'm going to have another vector. So I have to, the argument of this is a my vector v. So it's going to see if this my vector is equal to the my vector v in terms of its components. So what I'm going to do is I'm going to return, and I'm going to see, are the x components equal and are the y components equal? So I have, is this dot x equal to v dot get x? So this first thing says, is the x component of this object equal to the x component of the vector v? And then we also have to compare the y components. Is this dot y equal to the y component? Okay. And we're seeing if the x component is equal to the vector v's x component and the y component is equal to the y component. So I use the Boolean logical AND operator here. Okay? So these are some other methods that we might have in the myVector class. So that's basically the lesson. I'm just going to compile this. Oh, one note is that classes, when you're naming a class, you use the camel case convention. So each word has a capital, and you start out with a capital letter. So my is capitalized, vector is capitalized. Fields and methods also use camel case, but the first letter is not capitalized. So you can see that my, for example, my accessor method, it's 2 words, get y. The first one is not capitalized, and every word thereafter is. This is not something that you have to do, it's just a convention. So let's compile this and see if it runs. Or compile it and see if I have any errors. I'm sure I probably have an error somewhere. Let's see what it says. Whoa, no errors. Okay, I got lucky this morning. No errors in my code. So what we're going to do next time with SL is we're going to, today I just focused on how do you write a class, and on Thursday I'll talk about how do you use a class, how do you create objects and use the methods of the objects and so on, okay? So that is my lesson for SL, Computer Science SL. So now I would like to tell the SL students, stay on this YouTube live stream, but go to CodeBoard and start working on today's assignment, which is called Classes 1. So now I would like to talk to the HL students, okay? And we're going to talk about 2 recursive algorithms that I thought were kind of cool, all right? So let me go to my, so we're actually not going to use CodeBoard for this because I'm just talking about the algorithms. So this is computer science. What's today's date? The 14th. So the first algorithm I want to talk about is called the Tower of Hanoi. Okay? And it is a game where you have 3 poles. Okay? Let's call the poles A, B, and C. Okay? And you can have any number of disks. And the disks are like donuts. They have a, oh, there's a question. So review 2 and 3 were both assigned on Thursday of last week. So if you didn't do review 3, you can do review 3 today. But you're also going to have classes 1. Classes 1 is really quick, so don't worry too much about it. Okay, so you have these donuts that go over the top of each rod here. Okay, and you can have as many donuts as you need. Okay, so you know, that increases. I'm going to show you how it works for just 3. So you have 3 rings that are over the top. You have 3 rings that are over the top of the rod, okay? And the rule is you can move 1 ring at a time to another rod, and you can't put a bigger ring on top of a smaller ring. Okay, so what I could do is I could, gosh, I should have done this with pencil. Okay, I'm going to redraw this with pencil so I can erase. Okay, and so the objective of the game is to move all 3 of these over to the other side. Okay, so the first thing I'm going to do is I'm going to move the smallest ring over to here. Okay, so I moved the smallest one over to here. All right, And that's legal because there's no ring on this rod already. Then I'm going to move this one over to here. Okay, so now that one got moved. Now I'm going to move the smallest ring on top of the second biggest ring. So I erase that and I do that. That is valid because I'm always keeping a smaller one on top of a larger one. And then I'm going to move the biggest ring over, okay, which I can now do because there's nothing on rod C. Then I'm going to move the smallest ring over to here. Then I'm going to move the middle ring on top of the biggest one. And then lastly, I'm going to move the smallest ring on top of the middle ring. So you can see that I've gone from the stack being on the left side to the stack being on the right side. So this game is called the Tower of Hanoi, and you don't necessarily have to have 3 rings. So what I'm going to show you is an algorithm. What if you have n rings? Okay? So you have n rings. So there's n of these. Okay? So how can we solve the Tower of Hanoi in that case? Well, and you still have 3 rods. So let's call the rods A, B, and C. So let's say we're trying to solve the, so let's say we're trying to write a method, the Tower of Hanoi problem with n rings. And we also need to have a target. So where am I trying to move these n rings to? I'm trying to move them to rod C. Okay. I'm trying to do an autofocus here. Come on, autofocus for me. Okay. So how can I do that? Well, so let's say this is my code. What we want to do is we want to basically solve it for n minus 1 rings. So basically I'm taking the top n minus 1 rings and I'm going to move them to rod B. Okay. So once I've done that, what's the state of, so now I have, n minus 1 here. Then I know that rod C is empty, so I can take the biggest disk and move it over to rod C. So then I move nth disk to rod C. All right. And then, so now I have a situation that looks like this. Oh, by the way, so I actually have to be careful here. So when I do this algorithm, I have a target rod, and then I also have what is the spare rod. So I'm starting on A, right? And B is the empty one. So when I solve it, I'm going to go to, so you kind of have to, I needed some more arguments here. So I want to move, yeah. So you got to be careful here. And then lastly, once I've done that, I solve, again, the n minus 1 problem. but this time I'm trying to move everything to rod C. Okay? So this is a recursive algorithm for solving the Tower of Hanoi problem. Why is it recursive? It's because you can see that we're calling the solve function within the solve function. You also have to worry about the base case. So this game is really simple. So you can see that the number of disks gets smaller each time. So what is the base case? The base case would be you just have one disk. And how do you solve it if you just have one disk? Well, you just move that disk over to the target rod. So it's really simple with just one. So that's actually your problem for today. It's going to be to write a program that recursively solves the Tower of Hanoi with n disks. So the user types in the number of disks, and then it prints out the sequence of moves to solve it. That being said, I'm going to teach you about one more algorithm. And this is called, or one more problem, I guess. This is called the nqueens problem. Okay, the nqueens problem. And so this has to do with chess. So let's say you had an n by n chessboard. I'm going to take the case n equals 4. Okay, so you have a 4 by 4 chessboard. All right. And as you know, a queen can attack vertically, horizontally, and diagonally. Okay. So this is the 4 queens problem. But in general, it could be any number n. And we want to place the queens. So if it's a 4 by 4 chessboard, we want to place 4 queens on this board so that none of them are attacking any of the other ones. Okay? So for example, if you had 2 queens right next to each other, that doesn't work because those queens are attacking each other. So this method is called backtracking. So here's how it works. What we do is we just look at the chessboard and we just make an arbitrary choice. So I just place a queen. Boom. I'm thinking about this as like a book. Okay, I'm reading it left to right, line by line. Okay, so I just make a choice. I'm going to put the queen there. Now I'm going to look at what are the places that are attacked by that queen, and it's all these spots. Okay. Oh, I have 39 viewers. How do I have 39 viewers? I'm not going over, am I? That's pretty cool. So now what I'm going to do is I need to place 3 more queens. So now I'm going to recursively solve the 3 queen problem. Oh, it's Tam. Hey, how's it going? I'm going to recursively do the 3 queen problem where I can only place the 3 queens on these empty spaces that aren't being attacked. So what I'm going to do is I'm going to choose the next available spot. Okay. And I'm going to say, put a queen here. Now, where are the additional spaces that queen attacks? Well, this queen can attack horizontally. It can attack vertically. And it can attack diagonally. Okay? So then, I can place a queen here, and I can see that there's no other place to put a queen. So this didn't work. All right? So what I have to do is I have to go back. So this is where the backtracking comes in. You try to solve the problem, and if you don't solve the problem, you go back to where you ran into an issue to begin with. So don't have this queen anymore, and I don't have this queen anymore. So now I had all of these spaces empty, but now I'm not going to put a queen there. I'm going to put a queen here at the next available space. Now this queen is now attacking here and here. All right. So now I'm going to put the next queen in. The next available space is right here. But this queen can attack diagonally, and so we have no more space for an additional fourth queen. So we have to go back. It's called backtracking. Okay? And this is where we ran into the issue. So this queen was attacking this spot and this spot. So now we can't place a queen here or here because that won't lead to a solution. So we have to place a queen here. But then this attacks those other places. All right? So basically, you can see, so we have to go back again. And what we'll find is that if we start with a queen in this position, we can't place 4 queens, ever. Okay? So our initial choice was wrong. So we cannot place a queen in the upper left-hand corner. Okay? So I'm not placing a queen there. So where's the next available place I could put a queen? Right there. Let's see where it attacks. It attacks here, 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 here. Where's the next available place I can place a queen? Place it here. And this queen is attacking this square and that square. And then where's the next available place I can place a queen? Is right here. This queen is attacking this square. And we can see that we have an empty spot that is not attacked. So I can place a queen there. So I have 4 queens on the 4x4 chessboard, and I have found the solution to the nqueens problem, or the 4 queens problem, recursively. Okay? So that's my lesson. So let's go ahead and meet in the Zoom room.